In question number 18, a rod of mass m and length re is placed with its one end touching the surface of earth of mass me and radius re. Choose the correct options. So in option A and B, we have to find out what is the net force experienced by the rod due to the field of earth. So in order to calculate this, I am considering an element at a distance x of length dx. So the mass of this element would be m by re into dx. So the force experienced by this element can be written as df, which is equal to dm, that is m by re into dx, into the gravitational field at the location of the element, that is g into mass of earth divided by re plus x whole square, and the force is acting in this direction. Since the force on different element will act in the same direction, so we can calculate the net force experienced by the rod is integration of df, where x varies from 0 to the length of rod, that is re. So if I integrate this, it comes out to be g mass of earth, mass of rod divided by 2 times re square. So option A is correct and B is wrong. Now we have to check the validity of option C and D. In option C and D, it is asked about the center of gravity of the rod. So in order to calculate the center of gravity of the rod, now I am measuring the distance y from the center of the rod. So at a distance y, I am considering another element of mass dm, which is same as m by re into dy. So this separation is dy. So we know that in order to calculate the center of gravity, which is different from the center of mass, its coordinate y can be found out as y into df divided by df under proper limits. So if I do this integration, so df is equal to dm. So dm is m by re into dy into the field at the location of the element due to the sphere. So that is gme divided by y square. So if I integrate this from this to this, that is re to 2re divided by total force experienced by the rod, which I have already calculated. So that is gme into m divided by 2re square. So if I solve this, the position of center of gravity comes out to be 2r ln 2. So this comes out to be 1.4 re. So this is re. So let's check option C and D. The center of gravity of the rod is at a distance 3 re by 2 from O. So this is wrong. This is at a distance of 1.4 re. In option D, center of gravity of the rod is at a distance 0.4 re from the surface of earth. So from the surface of earth, the separation comes out to be 1.4 re minus re. So it comes out to be 0.4 re. So option D is correct. So the correct answer for question number 18 are option A and D. Let's move to question number 19. In question number 19, a particle of mass m is to be projected with velocity v0 from point P located at a distance 2r from the center of earth. Values of v are given in column 1 and corresponding characteristics of path followed by particle are given in column 2. So let's check the entry A of column 1. So entry A of column 1 suggests the value of v0 is under root gr by 2. So if I calculate the required centripetal force at this moment, so the required centripetal force at this moment is equal to m into v0 square, so that is gr by 2 divided by r. So r is 2r from the center of earth. So it comes out to be mg by 4. So at this moment, if I calculate the gravitational force experienced by the particle due to the earth, then the gravitational force experienced is m into gm divided by 2 times r whole square, so 4r square. So again this gm by r square can be written as small g, so it is mg by 4. So in this case, the required centripetal force to move in a circle is provided by the gravitational force. So in option A, the correct matching will be circular path. So Q will be the correct matching. Let's check entry C, in which V0 is greater than under root GR. So in this case, if I calculate the total energy, then total energy is gravitational potential energy, that is minus G capital M small m by 2r plus kinetic energy. So I am calculating kinetic energy when V0 is equal to under root GR. So that is equal to half into M into V0 square. So that is G into R. So G is G capital M by R square. So this is R square into R. So if I calculate this, it comes out to be 0. So when V0 is equal to under root GR, then total energy becomes 0. And when V0 is greater than under root GR, then total energy is greater than 0. So it means that the particle, so when the total energy is 0 or greater than 0, then the particle escapes from the gravitational field of Earth. So it escapes to infinity. So the correct matching will be T. Now in option B, V0 is greater than under root GR by 2 but less than under root GR. So it means it follows the elliptical path with point P at the perigee, that is the closest distance from the center of Earth. So the correct matching will be P and R. And when V0 is less than under root GR by 2, again it is elliptical path, but now point P is the point of apogee, that is the farthest distance from the center of Earth. So in this case, the correct matching will be R and S. So for question number 19, the correct matching for entry A is Q, for entry B it is PR, for entry C it is T, and for entry D it is RS. Let's move to question number 20. In question number 20, an object O placed along optical axis is moved with velocity of different systems mentioned in column 2. Velocity of image is mentioned in column 1. So if I check the first entry P, then since it is a plane mirror, so in case of plane mirror we can say that velocity of image with respect to mirror is equal to negative of velocity of object with respect to mirror. So velocity of image minus velocity of mirror in this case is 0 is equal to minus velocity of object is 10 I cap minus 0. So from here the velocity of image comes out to be 10 into minus I cap. So the correct matching will be 10 meter per second. So one of the matching is P. In entry Q, since the mirror is moving with a velocity of 5 meter per second, so I can write velocity of image minus 5 into minus I cap is equal to minus of 5 I cap minus of 5 minus I cap. So that is plus 5 I cap. So from here the velocity of image comes out to be 15 minus I cap. So the correct matching will be Q. Now in entry R, it is a concave mirror. So in case of concave mirror, the velocity of image with respect to mirror is equal to minus m square times velocity of object with respect to mirror. M is V by U. So if I see the radius of curvature of the concave mirror is 20 centimeter and the separation is also 20 centimeter. So it means that the object is kept at the center of curvature of the concave mirror, so its magnification is 1. So in that case, I can write velocity of image minus velocity of mirror, that is 0, is equal to minus 1 whole square into velocity of object, that is 10 I cap minus 0. So from here the velocity of image comes out to be 10 minus I cap. So the correct matching will be B. So the B have a matching P and R. Now in entry S, so we can write velocity of image minus 7.5 minus I cap is equal to minus magnification is 1 square into velocity of object, that is 5 I cap minus of minus 7.5 I cap, that is plus 7.5 I cap. So if I calculate the velocity of image, then it comes out to be 20 I cap. So it comes out to be 20 minus I cap. So the correct matching will be D. So D have a matching S. And in the case of lens, the velocity of image with respect to lens is equal to m square times velocity of object with respect to lens. So velocity of image minus velocity of lens, that is 0, is equal to, since the object is kept at the 2f, so the magnification is 1 square into the velocity of object, that is 5 I cap minus 0. So from here the velocity of image comes out to be 5. So the correct matching will be A, and A have a matching T. So the correct answer for question number 20, for entry A it is T, for entry B it is PR, for entry C it is Q, and for entry D it is S. By this, I wish you all the best for your preparation. Have a good luck. Thank you.